Hey everybody, here is another quick video to show you how to take this second quiz in Khan Academy for sequences and series. All right, so let's go. We are practicing a bunch of different skills. The question will kind of tip you off as to what you're supposed to do. In this case, we're just asked, is this series convergent or divergent? This is as simple as they come. It's that P-series test. Is that number there? Is it 1 or bigger? Because if it's 1 or less, it's going to be divergent. If it's bigger than 1, it will be convergent. So that's what it is. If we have a series like this, and they're just saying what are the values of P such that this converges, we need to be mindful of the fact that it's alternating, and that means that all we need is for this to be decreasing, positive, and continuous, and we are good to go. In this case, we need that P to be negative, right, to put it in the denominator, and then to be negative 1 or less than 1, okay? Or actually, we can have that as long as that is negative, we're good because of it, because it's alternating. If it's down below and it's n to the 3, that's definitely going to converge. If it's n to the 1/2, it's going to converge because it's alternating. All right. So all we need is for it to be less than 0. I'm going to go with A on this one. There we go. Even got some sparkles that time. So next one. What is the conclusion that can be reached by using the nth term test on this? We just want to take that out to infinity land and see what's happening. If it's going towards 0, it could possibly converge. We just don't know. Could be harmonic. But if it's not 0, we know it's diverging. So let's see. When that goes out to infinity, we're going to have n to the 3/2 essentially in the denominator. That is going to 0. But that is not enough to tell us for sure what's going on. It's all about divergence. It's the nth term test for divergence. All right, so now next one is, what would we compare this to in order to see whether this converges? Well, this is an n over an n squared. Don't let that 2 bother you. It's really all about n over n squared, which when you cancel an n is 1 over n. That's harmonic, so I'm going to compare that to the harmonic series. That'll tell me what's going on. Whoops, I got to read the whole problem. If it's harmonic, if it's 1 over n, we know that baby diverges, all right? Next one is, when applying the integral test, we get a limit. Oh, these are always fun. What that determines whether the series converges or diverges. All right, so, oh, this is good. This is good. We have right down here 1 plus n squared. That's the derivative of an inverse tangent. When I integrate this using the integral test, I'll get an inverse tangent. Take that 2 out and then put it back in to tan to the -1. Here's the only one that has tan to the -1. When I plug in 1, yep, the inverse tangent of plus 1 or whatever, or -1, is going to give us that minus pi over 2. Next one is, read the directions please. Based on your answer, looking at this, okay, this is a ratio test. What does that ratio test tell us? Okay, here's where we maybe need to do a little bit of math. It's going to be 9 to the n plus 1. Sometimes when you get good at this, you can do this in your head, but I'll give you a little bit more explanation here. That's the n plus 1 term up on top, over n plus 1 is n plus 2. And then I'm going to have 2 to the 2n minus 1. Well, that's going to be 2 to the 2 times n plus 1 minus 1. Got to just, wherever there's an n, put in an n plus 1. Don't just tack a plus 1 on there. You need to distribute the 2 in, and then that's a minus 1. Okay? So what does that actually become? That becomes 2n plus 2 minus 1. That's 2n plus 1. So if I just want to be super clear, that exponent will be then 2n minus 1. All right, there we go. And then that's times, and don't forget this is a limit, blah, blah, blah. I'm going to put that there. And then we've got this other fraction, which is this original thing, just as it is. I'm not going to write it. We just need to imagine that it's right there. And then we put it like that, and we say that's less than or equal to 1 with a question mark. So when I do that, I'm going to have one more 9 when this 9, n plus 1, cancels with this n down here. That's going to be just a 9 right there. And then n plus 2 and n plus 1, n over n are going to cancel each other off. And whoops, I didn't mean to do that. Sorry, how do I get rid of that? There we go. And then I've got 2n minus 1, and I've got, oh sorry, that's plus 1. Wow, caught my mistake. 2n plus 1 times 2 is 2. 2 minus 1 is still 1. Maybe you guys saw that early on, but that's how you catch your mistakes. And then 2n minus 1, that's a difference of 2. Okay, there are 2 more 2's down below. So that's 2 to the second is 4. And then as these n's cancel, I think as n goes to infinity, I'm just going to get 1 over 4. Hopefully I'm not making a mistake on that, going kind of fast. And if it is 1 over 4, that tells me that that is less than 1. So this series converges, all right? Well, let's see where I made a mistake. I'm probably just going too fast, so let's see what I did wrong. This is the learning opportunity. Wow, why is it 9 over 4? Because I left off a number. Oh, it's the 9. Oh, I just forgot the 9. Okay, I circled it there, and then I just didn't write it there. I'm so sorry, but you're going to do that too. And I thought I was going a bit fast. So don't let that bother you. You want to get a good score, maybe not a perfect score, okay? So moving along. What do we have to do? We have to correct this. 9 over 4. Nope, and then if it's 9 over 4, this series diverges. So I was at least consistent on that part, if it had been 1 over 4. The next one is which series converges. Okay, so that's the only question, which series converges? All right, well, it looks to me like this is alternating, but those terms have to get closer and closer and closer to 0, and they do not, okay? They do not get closer and closer to 0, they get closer and closer to 1, so this one does not. This one also does not, because that is just getting closer and closer to 1, and if you add 1 up a bunch of times, you're not going to get a convergence. So which series converge? We're going to say neither. Neither. Oops, what is that? Sorry, keep reading the question. Based on your answer, what can we say about x, s? If one does and the other doesn't, then you'd say that conditionally converges, but neither do, so the series converges, the series diverges. There we go. All right, last one. We know that this one definitely converges. 5 is bigger than 1, okay? If this one is bigger than the one that converges, right? So if this one is converging, that's going to 0 fast enough that we can figure out what this total is down here. Does that tell us anything about something that's bigger than it, like up here? Heck no, that is not conclusive. So that is the comparison test failing to be of any real use. The test is inconclusive. Okay, so apart from my one brain fart on that one problem, that was a pretty good quiz. Hopefully you can do the same. Good luck, everybody.